Now we're going to apply what we know about intermolecular forces to physical changes. Physical changes for a compound are things that are changes to a physical property that doesn't change how the atoms are actually bonded together. And so the structure of our molecule stays the same through a physical change. A chemical change would actually change what that molecule looked like, how the atoms were bonded together. So, physical properties that can undergo changes, but physical properties include things like the vapor pressure, the viscosity, the surface tension of a liquid. It could be the smell or the color of a compound. It could be the temperature at which it boils or it freezes, things like that. So we're gonna not go through all the many different types of physical properties that exist and talk through how intermolecular forces can be used to compare two molecules and determine which property is one way or the other. We're gonna focus in on phases of matter and phase changes. So a phase of matter is a physical property. And the phase of matter will be either a solid, a liquid, or a gas. There's also plasmas, but those won't really apply to what we're working on here. So we're just going to focus on these three. And so a solid is going to be something that has a very fixed shape, like and volume. If you were, you could like hold it in your hand probably. A liquid is going to have a fixed volume, but it's going to take on the shape of whatever container you put in it. So it has more movement to it. And a gas will not have a specific volume. It'll just expand to fill whatever container you put it in. So it'll take on the volume and the shape of the container it's in. And so I think the one that's most intuitive for everybody is to think about water. This is something that we interact with in all different phases of matter. So water we have as a solid ice, as ice cubes, and liquid water we might drink. And then gas as or water as a gas is steam. So when we're boiling water to make some tea and we have all this steam coming out, that's just gas. That is water. It's water molecules in the gas phase. And so the difference between these three states of matter is really how much motion the molecules are experiencing. So in a solid, our molecules stay really close together in a highly ordered way. And they really don't change their position relative to one another. They'll still vibrate and maybe rotate a little bit and stretch their bonds, but they'll stay next to the same other atoms or molecules in the solid. Once something is a liquid, each of the molecules or atoms has a lot more motion. It's going to, a molecule will tumble around another molecule and around all of them, and they'll all just kind of be tumbling all over each other, but moving rather than staying stationary in the same place. This type of movement is translational movement. So it's translating through space or tr- transiting through space. And so in this liquid, I think of this as like they're all, it's hard to draw tumbling molecules. I'll throw some arrows. But the thing that's important is that they're all very close to one another still and in close contact. Then a gas, these molecules or atoms have even more motion. In fact, they have so much motion that they have a large separation between each other and they're zipping around this container, the space that they're enclosed in. And so as we go from solid to liquid to gas, all of these molecules are getting more and more motion. This is kinetic energy. So if we go back to thinking about energy, potential energy is stored in chemical bonds. Kinetic energy is the energy of motion. And so we're increasing the kinetic energy of our matter as it changes phase from a solid to a liquid to a gas.